All right, welcome, ladies and gentlemen, to another live stream. I have some great questions I look forward to sharing you with this evening, and I know many of you are kind of in the middle of your exam prep, so I do appreciate you joining in, and hopefully some of the topics that we're going to cover tonight might be beneficial for whatever math class you are taking. But in regard, even if it's not, I do wish you guys all the best on your exams. If you've already taken maybe your math or you have some other exams coming up, I wish you guys the best, and I know it's a tough couple of weeks, but hopefully we all get rewarded with taking some weeks off to refresh and then get going for the second half of the year. So to get this live stream off, I am going to cover some problems here. Just regarding graphing some exponential function. I had a lot of requests for this live stream as far as graphing. So I'll start off with graphing some exponential functions, and then, you know what, I'm actually just going to relay that to like how the natural logarithm graph is going to look, just so you can kind of see like those transformations. And then it looks like a lot of students are also very similar to where I'm in my class with graphing trigonometric functions. So I actually don't cover graphing anymore for trigonometric functions. I used to teach it like very in depth in my class, and it just kind of took away from the actual like understanding of what we're doing, why we're doing. So I stopped really diving deep into the graphing trigonometric functions. And I see Panos Abdra, do you have an integrated math 3 exam? No, I do not. I only have pre-calculus. But thank you so much for the super chat. I'm going to try that logarithm one that I know you requested. So hopefully that will help you out. But thank you again for super chat. I do appreciate it. And welcome to everybody else that's going on. I will do some hellos here in just a little bit, but the super chat caught my eye, so I wanted to make sure I could get my thanks out there as quickly as I could. So I will cover the sine, graphing just the sine, showing you how to do the x scale, showing you how to do kind of the start and the end of the initial period. And then also doing the tangent was another problem that was requested. And then actually even in particular, this y equals 2 tangent of 3x plus pi. Just kind of at least get that one started so you guys can kind of see how that works for graphing our trigonometric functions compared to our other functions. And that's going to take up a lot of it. But then also I'm going to do a solving a system of equations by graphing. So it's in slope-intercept form. Obviously, if it's not in slope-intercept form, you just want to put it into there. And then I am going to have a problem for finding the inverse of y equals e to the x plus 3. Then we'll talk about direct variation. So very good job this time, guys. You had a lot of questions that came into me from the community tab as well as in the chat before. I do try to always check into the chat once in a while. But, as I mentioned, guys, unless you're sending me something on Facebook or on my community tab, a lot of times, my computer will need to be refreshed, or I'll have to close the browser, and then I won't be able to get back into a lot of those previous questions that you guys send in there. So please make sure if you do have some questions for the next live stream, which again, we would go live. I'm just going to say it now because I think I've been pretty consistent every Sunday at 9 o'clock p.m. Eastern time that I'll be going live. So if you plan on having some questions you'd like me to address, I obviously cannot cover everything, and I'm only going to be going live here for roughly around 30 minutes. So I don't have time. A lot more of the advanced problems, pretty much calculus and above, as well as like word problems, I'm just not able to really fit into our schedule. I want some problems that I can kind of quickly and address. And obviously I'm teaching pre-calculus this year. So really anything around there, I can kind of address quickly, at least onto the live stream, and not have to do too much prep work or remembering a lot of things to do that, because I really only get about 30 minutes before I go live, look at my questions and get everything all set up. Kix gives another one. Can you try e to the x plus e to the negative x equals 1? Kix, thank you so much for the super chat. I am sorry, though. That's just not something that I want to work on as far as being able to work through it like on a live stream. And that's what I was kind of getting into it. Like as far as these advanced problems, I'm not sure about you guys. I'm not sure how familiar you guys are doing with like math problems during a live stream and random people on the internet are watching you work through a problem. But yeah, it's not really the most ideal environment for me to be able to do. So obviously a lot of things that I do every day in my classroom, I can usually address, and it's a little bit easier. But, for a problem like that, that's something that I don't see every day or something that I'd want to think through it. I want to make sure that I can do justice to my explanations for you guys, and also do justice for like the reasoning and why we're doing everything. So that's why I just kind of like put the line in sand saying, hey, I'm just not going to be doing anything more advanced, at least that I'm just not comfortable with explaining, because one, I want to make sure that I can deliver you guys a good explanation. So, Kix, I'll make sure that I will, since you did do the super chat, I will give you a little bit of 5 minutes of my time. And then I will, hopefully if you reach out to me on my community tab, I will respond back with maybe some of my elements, or at least my approach that I got onto that. So I'm not going to cover through the live stream, but please reach out to me on either on Facebook or on the community tab, and I'll respond to you there. So, because again, I really do appreciate the super chat, so I want to make sure I can, give you something back in return, even though I'm not going to be able to do the question. But all right, guys, we got 6 minutes into this. I see 2 Exander free mail. Kix, was on my last pre-calc exam. I tweeted, like I said, and the other thing too, it also let you know I'm not even saying like calculus or advanced. I'm just saying that it's just not something that, like that question is something that I've worked, like in my calculus, we actually don't even teach logarithms anymore. It's kind of crazy. So it's just not something that I'm like a very obvious. And anyways, I'm really kind of tight on my work in there, but I'll be more than happy just after I'm done with the live stream, just go and take a look at it, and to actually put some mental thought into it and then get back to you. So, that's what I say. I'm just kind of holding off as far as anything that, anything else that as far as a, initial, problem from there that I'll get through, but I'll be more than happy to give you some time for that, because I do appreciate that super chat. The Kitty Gamer, 44 views. Thanks. Thank you very much. Yeah, I know we got to get ready for these exams. So hopefully I can do everybody help. Looks like we got some good variety of the problems. I'll try to do my best trying to give you guys some explanations, but then also try to keep things going around, because that's always like the difficult thing when I'm doing these live streams, regarding is looking into giving you guys a solid explanation, hence what I was talking about, like with that one, not only doing a solid explanation, but also not getting like too in depth with everything. So therefore I'm spending too much time on that. But hi, Amanda, good to see you. And Xavier and Nathan, thank you very much, guys. I really do appreciate you guys joining in. And you, Karsh, I guess is the thing. Can you do a quick review on logarithms? I am going to do a little bit of logarithms. I'm just kind of full, guys, on this live stream. I do apologize. You know what? Maybe, let's ask this. I might be able to do a bonus live stream. We'll maybe kind of do that. Yeah, maybe we'll kind of do like a review. Maybe I might do a bonus live stream. I don't know. I don't know why I'm committing to this. This is more time for me. What am I doing? But either way, I'll let you guys know. I think I'll maybe post on my community tab. I'll let you guys know. Maybe I'll do another bonus stream, because I see a lot of questions are coming through, and a lot of you guys have some things that you want to get addressed. So I might be able to do something extra this week. We'll see. I think maybe Wednesday I might be able to do that for you guys. So I'll go and look at my schedule. Adeline runs in late. Sorry, take my tea. Hey, absolutely. Come on in. Actually, I haven't got started. I've just been rambling on, saying hi to everybody and getting through. But you know what? Let's just plan on that, guys. Let's do a Wednesday, 9 o'clock. I'll make sure I'm going to do live again. So if I don't get to your questions, which I'm not going to, for a majority of you that are joining in, I do apologize. I have 7 questions here. That's really going to take me to the end of this live stream. But I will do a bonus on Wednesday. So make sure you guys, if you have questions, I'll make sure I put that link up there probably after this live stream, and therefore you guys can start getting those questions coming into me. We'll do this way in advance this time, since I'm now committing to another live stream this week. So, all right, I got to start talking. We got to do some math. So let's go into the graphing exponential function. So the main idea, guys, when we're graphing exponential functions is, really understanding what the parent graph looks like. And y equals e to the x has a y-intercept at 1. And the graph is going to look something like that. Okay, again, I'm not going to be perfect here. Now, again, it doesn't matter what the base is. If it's e, if it's 2, if it's 3, if it's, whatever that base is, it doesn't really matter. It does matter. It is going to change the shape of that curve. Yet, it's still going to have a y-intercept of 0, 1. and it's going to basically hold this shape. Now, it is important as far as domain and range goes that you understand there's a horizontal asymptote here. So therefore, this graph has a domain of all real numbers and a range from 0 to infinity. All right. So in this next example, we just got to understand the transformations. When we're multiplying by a negative on the outside, what that is doing, that is reflecting about the y-axis. So we basically have this graph being reflected about the y-axis, and then I'm adding a 1 in the exponent, so therefore that's going to be shifting the graph 1 unit to the left. So basically what I can do here is I can reflect the graph about the y-axis. So now the graph is going to look something like this, and then you'll just move it 1 unit to the left. And yeah, something like that. But either way, you can see though some things change here. The domain is still going to be the same. The graph is still going to be going to negative to infinity and to the right infinity. However, the range though is now from negative infinity to 0. And remember, 0 is not included. There's a horizontal asymptote there. So, this horizontal transformation is not impacting my graph at all, or I'm sorry, is not impacting my domain and range. The only thing that's really impacting my domain and range is this reflection about the x-axis. So, and again, my curve is just really bad, so don't worry about that. As far as the 1/2 e to the negative x, so now basically what we have here is we have a vertical compression. But again, that vertical compression is not going to be changing the asymptote or the x-intercept. That is just going to be compressing the graph. However, now I do have a reflection about the y-axis, and the graph is going to be shifted up 1. So instead of having a y-intercept at 1, actually, I'm sorry. I do actually forgot. It's been a while. We haven't taught these. Actually, what this actually does, I kind of totally forgot about that. This actually is going to change my y-intercept as well. So instead of my y-intercept being at 1, it would now be at 1/2. So when I move it up to 1, so therefore it's actually going to be at 3/2. So that's a little confusing. Don't want to get too in depth here. But basically, if you think about like y equals e to the x, when you plug in 0 and for x, you're going to get 1. So when you multiply by that by 1/2, that's why we're at the 1/2 here. Then the graph gets shifted up 1, and then again it's reflected about the y-axis. However, I got shifted up 1, right? My bad. So it was at 1/2, and then it got shifted up 1. So let's actually 1/2. Let me actually fix this. Okay, so there's a lot going on here. So the y-intercept was at 1/2, and now the y-intercept is going to be at 1 1/2. Since the graph got shifted up 1, though, instead of the asymptote being at 0, now the horizontal asymptote is at 1. And then the graph is obviously being vertically, compressed. So now my domain is still all real numbers, but my range is from 1 1/2 to infinity. The only really difference, guys, with a logarithm compared to an exponential is, if you recall, these are inverses of each other. So inverses of each other are reflective about the y equals x line. So the logarithm, we would graph this basically using the same idea and same approach. The only difference now is this graph is going to have a vertical asymptote at y equals 0 and a x-intercept at 1, 0. So that's really kind of like that difference there. And then again, but the transformation, this is the main thing that I really try to drive home with my students. The transformations impact the graph the exact same. It doesn't matter if it's a logarithm, an exponential, or some trigonometric functions. Now, trigonometric functions, though, do have some new vocabulary that we're going to talk about. In addition, graphing them is a little bit more difficult for students because here, for all graphing functions, I just tell students you need to know transformations and you need to know what the parent graph looks like. Basically, the graph with no transformations. Because as long as you know what the graph looks like with no transformations, you just apply what the transformations are to that original graph. So in this first one, we have y equals sine of x. I don't know why I'm doing so many of these. You know what? Let's do that. Forget that problem. I'll put 2 there. We'll do the problem that was requested. Okay. And then I'll just delete that. I made up some problems for a... Okay. So sine of x. Let's go ahead and get the parent graph here. So this is what we call the initial period, because obviously sine is going to continue in both directions infinitely. So the parent graph here, or the initial period, is going to go up to 1, down to -1, and to 2 pi. All right. So if I wanted to graph this, and this again, I'm just specting on graphing. We know this 1/2 is vertically compressing the graph, right? That's also telling us the amplitude, which is going to be one absolute value of 1/2, which is 1/2. So basically what's happening here is instead of the graph going up to 1, down to -1, like it did over here, now the graph is only going to go as high as 1/2 and as low as -1/2. Then also the graph is being shifted up 1 unit, right? So if the graph has a range from -1/2 to +1/2 and it just got shifted up 1, then now the graph is going to be from 1/2 to 1/2 plus 2/2 is 3/2. And then also, then we have to look at, well, what is the 2 doing? Well, remember the period of sine is 2 pi. So basically, this is what we need to know. So the period is 2 pi divided by b, which in this case is 2, which is pi. Okay, so instead of the graph taking 2 pi to repeat itself, it's now taking pi. Now, when you're doing graphing, what I like to do is do the x scale. So the x scale is basically you take the period and whatever the period you found and then just divide it by 4. Well, in this case, you can see that pi divided by 4 is just pi over 4. And then we like to do the start and the end. So again, this is the way I used to teach it. So the start is whatever's inside your function equal to 0, which is still going to be the same, x equals 0. And the end is whatever was inside your function, 2x is equal to was equal to 2 pi, where you could say x is equal to pi when you divide by 2. So let's go through this graph here real quick. And again, I'm just going to do an initial period. So the graph period, it's going to go from, well, all right. So if you recall, here is our 1. Remember the low point was at -1/2 to 1/2. It got shifted up 1. So now my low half is going to be at, here's 1. Let's do this as 3/2. That's 1/2. So the graph is going to go up, down, and over. A lot of times I just do this y-intercept there. That's going to be at pi. And then this scale, this x scale is basically how many terms, like you can see here that's going to be pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. So what the x scale basically does is give you these important points here, which are the maximum, the x-intercept, and the minimum in your period. So again, these are going by 4s. So it's pi over 4, 2 pi over 4, which is pi halves, and then 3 pi over 4, which I kind of ran out of space. And then you can see how that ranges. You know, now the graph got shifted up 1. And again, I'm just doing a rough, not a very good detailed explanation, but hopefully you guys have some bearing from, like some kind of foundation for graphing that you can kind of catch on to what I'm doing. Because in my class, we just focus on finding the period, the amplitude, and the transformations. So in this one, you can see that now my graph is being shifted pi units to the right. So my range is still from -1 to 1. That nothing vertically happens. Now the graph is just being shifted pi to the right. So the period is still 2 pi. X scale is going to be 2 pi. Let's do the x scale. So this is different now. So the x scale is 2 pi divided by 4. So whatever the period is, divided by 4. So in this case, it's going to be pi halves. So again, when I graph, I do this start and end. So the start is whatever's inside your function equal to 0, because again, that's the initial period. The initial period starts at 0 and ends at 2 pi. So you just take whatever transformation, excuse me, any transformation inside, which is going to be what's inside the function, equal to 0. So now we're going to start at pi. Oh, yep. And then we're going to take the end, which is whatever's inside your function. And that's equal to 2 pi. So now x equals 3 pi. All right, now as far as the graph going up and down, that's the same. So now I'm just going to start And instead of calling this like the x-axis, I'm going to say, well, this is at pi, and here's 3 pi. And then the x scale is changing every pi half. So this one's kind of a little bit weird here as far as it goes. So it might be easier to write everything in terms of halves. So for instance, pi is really 2 pi halves, right? So then the next one would be 3 pi halves, 4 pi halves, 5 pi halves, and 3 pi is 6 pi halves. Again, we're going by these x scales periods of 4, right? And then nothing changes vertically and negative, so therefore that's going to be my max, that's going to be an intercept, my minimum, and from there. So the graph is going to look something like that. And again, I don't like to spend a lot of time on this. As far as identifying the x scale, I just use graphing technology, I think, is a little better use of the time. So as far as on tangent, I think, yeah, we can just go and graph these. That's fine. Again, I'm just going to graph the initial period because, again, all you would do to do more than one period is you just keep on adding those x scales. So that's why it's very helpful to find the x scale, which is whatever the period is divided by 4. Now, as far as for tangent, I don't do the period divided by 4 for the x scale. I do the period divided by 2 because when you look at the tangent function, there's only two important points. There's the asymptotes and the x-intercept, and that's it. So let's go ahead and take a look at this one. So here, my period is, so now, and again, this one's kind of weird too, for when I'm doing this for tangent. Now again, remember the period is pi divided by 1/2. So that's equal to 2 pi. So again, remember tangent has a period of pi. So if the period went from pi to 2 pi, you can see that obviously the graph is horizontally being stretched. As far as my x scale goes, what I like to do here is I just take whatever my period is, 2 pi, and I divide it by 2. So therefore that one equals pi. Now as far as the start and the end go, if you remember the initial period for tangent, which I'm not sure why I didn't do, here, I'm not going to graph this one, but let's just do y equals tangent of x. Remember the initial period looks like this. Which is at pi halves and negative pi halves. So the start of the initial period is going to be whatever's inside your function equal to negative pi halves. And the end inside your function is going to be whatever's inside your function equal to positive pi halves. And then just go and solve for x. And so in this case, we get negative pi, and x is equal to pi when you multiply by 2 on both sides. So when I go ahead and graph this, I'm at negative pi and pi. And do my nice little asymptotes here. Bad asymptotes. But you can see that, yeah, the period's going to be 2 pi, which we already kind of knew. And then I'm just going to do a really bad S-curve because it intersects there at 0. There's nothing been shifted up or down. The only thing that did change, though, is the graph was shifted down 2 units, right? So actually, my graph is going to look something like that. So let's actually erase that one. Okay, but again, like you can see how that start and the end kind of help us as far as the graphing goes. And the X scale would really only help you as far as if you needed to do like 2 periods. Like typically that would be asked on a test would be like do 2 periods. So then you just know your X scale is just gonna be adding pi. So the next intercept is gonna be at 2 pi. The next asymptote would be at 3 pi because you just keep on adding pi's. The important thing to remember from tangent, at least some common mistakes here, is remember tangent doesn't have an amplitude. There is no max and min, right? This is infinitely rising, rising without bounds, up and down. So therefore, as far as the tangent goes, this 2 is just going to be a vertical stretch. So it's actually not going to be impacting the graph at all. Now, as far as understanding the transformation, I told my students the best thing that we want to do is be able to factor out that b. When you factor out the b, remember thinking of factoring is like dividing out the 3. And think about dividing by 3 is the same thing as multiplying by 1/3. What would happen if you multiply both these terms by 1/3? You would get x plus pi over 3. And again, you can always check your work. 3 times x is 3x. 3 times pi over 3 is just pi. But my preference when you need to graph this is let's go and find the period in the x scale. So the period is going to be pi divided by 3. That's your b, which is nothing really you can do. The x scale, if you need to do more than one period, I just like to do my period divided by 2, multiply by 1/2. That's going to be pi over 6. So then my start, this is a lot to work with, is going to be 3x plus pi equals negative pi halves. And then my end is 3x plus pi equals positive pi halves. All right, so if I add pi, that's going to give me a positive pi halves, and I divide by 3, that's going to give me negative pi over 6. So you guys can do your work to verify. Here, if I add pi, that's going to give me a 3 pi over 2, and if I divide by 3, that would give me a 3 pi over 6, which would give me a pi halves, which no, wait, I'm subtracting. That's right. Positive pi's. Yeah, if you subtract, that's going to give you negative pi halves. Wait a minute, what happened here? That's a negative pi, that's a positive pi. 3x plus pi. Oh, I did that wrong. My bad. All right, fine, I'll just do the work. So you subtract pi on both sides. That's a negative 2 over 2, negative 2 pi over 2, negative 2 pi over 2. So I get a 3x equals a negative 3 pi over 2. Multiply by 1/3, if you want to think about it like that. Right? Multiply everything by 1/3, so I get x equals, this would give me a negative 3 pi over 6, which can be reduced down to negative pi halves. There we go. So here, I'm going to subtract a pi. That would give me 3x equals a negative pi halves. Again, multiply by that 1/3. X equals, what was my scale? X equals 2 pi, 3 pi. X equals a, oh, because it's getting shifted pi over 3. That's going to be multiplied by 1/3. So that's going to be negative pi over 6. So I got enough room for this one? Barely. All right, so we're at a negative pi halves. And you know what? Let's forget about this. Now again, that's negative pi halves, but if you want to think about that in terms of your x scale, think about that in terms of, well, actually, you know what? I'm just going to, and this would be a negative pi over 6 as far as my endpoint. So that's where my two asymptotes occur. Now, the question is, though, like, where's this x-intercept? Well, again, like, this is your x scale, right? So that's the nice thing why I do it by 2. Is like, here is an important point, here's another important point, there's another important point. So my x scale is pi over 6. So if I just take negative pi halves and add my next x scale, pi over 6, that's going to give me this coordinate point, which is, again, it's like, I think in my point, it's like too much work, really, for the purpose of it. Plus pi over 6. That's going to give me a negative 2 pi over 6, which is equal to negative pi over 3. There you go. And that would make sense. And then if you add a, so negative 2 pi over 3, I hope my math is right. Because then if I added another pi over 6, is that supposed to be negative 1/2? Add another pi over 6. Now this problem is taken to the, add another pi over 6. That's going to be a negative 2 pi over 6 plus pi over 6. Yeah, which is a negative pi over 6. Okay, so I'm working good. So anyways, that's going to be your answer. Obviously, your y-intercept there. And then you can just keep on adding pi over 6 to get to your other points. All right, I'm not going to graph this one. The only thing I want to make sure that you understand is, again, to make sure that you rewrite this tangent of negative x plus pi halves, and just make sure you factor out that b. Nobody asked me for this equation. I just made it up. But the important point here, guys, is making sure that you guys factor out that negative. All right, I see some of you guys, a lot of them are put into your chat, and I really do appreciate it, guys. I'm obviously, if you're just kind of getting in, I will be planning on going live this Wednesday because I know that a lot of you guys are doing finals and semester exams and all that kind of stuff. So hopefully, if you have some additional questions that I can help you out with as far as your studying or explanations, I will be putting a notice in my community tab for you guys to go ahead and start submitting some questions there. So, and I'll try to work my way a little bit faster because I'm already kind of at the end of my point, but I got about 10 more minutes. So I will try to finish off these questions and then obviously get to you guys on the chat that I know kind of came in once I started going live. So I got 3 more questions, 10 minutes, and then I'll get to you guys on the chat. So I really do appreciate you guys staying with me here on the live stream. All right, so the next example is solving a system of equations by graphing. And remember, when we're trying to find this, when we say solve the system, we're trying to basically find the values x and y that make both equations true. So in a graphical sense, that's going to be where those two graphs are going to intersect. So when we want to graph, when we want to solve by graphing, we basically just want to graph both equations separately and then find the intersection point. And you could get the equations in point slope form, standard form. In this case, I chose to do slope intercept form. And it really just kind of comes into graphing them and then being able to identify the point where the two graphs intersect. So let's just kind of graph both these equations and then identify that point. So just a reminder, when we're graphing in slope intercept form, mx plus b, where b represents the y-intercept, which is 0, b. And then m represents the slope. And remember, the slope is going to be the change in the y-coordinates over the change in the x-coordinates. So to graph the first one, I'm going to go up to 5. 1, 2, 3, 4, 5. Okay. And now my slope is negative x. So really what that is that's you want to find the slope here. When you have y equals negative x plus 5, remember, we can rewrite that as negative 1, right, times x plus 5, which could also be rewritten as negative 1 over 1 x plus 5, which is the same thing as positive 1 over negative 1 x plus 5. So again, it doesn't matter if the negative's in front, it doesn't matter if it's in the numerator or denominator, all of these are all the same. Now, typically we want to go ahead and graph, typically, all we need is 2 points. But when we're solving a system, we want to find the point where the two graphs intersect. So in the same respect, that's what we want to, possibly sometimes do in the positive or in the negative direction to kind of see where these graphs are going to intersect. So let's look at the next equation, which in this case would be 1/3 x. So in this case, our slope is a fraction, 1 over 3, which a lot of times you can also think of, as rise over 1, going up 1 over 3. There is no b, so we can say that is going to be 0. But again, we can also look at this as a negative 1 over negative 3x plus 0, right? So instead of going up and over, up 1 unit, which would be a positive change in the y, over positive 3 to the right, we could also go down and to the left. So, but the y-intercept is going to be at 0. So let's go up 1 and then over 3, 2, 3. Okay, and you could go down 1, 1, 2, 3. All right, so just by doing this, I'm just going to do 3 points because I want to kind of get an idea of where these graphs are going to intersect. Well, if here's my graph, I really don't want to go to the left. I want to go to the right, to try to find out where they're going to intersect. So what I'm going to do is I'm just going to keep on following the slope until I get to this line. So I'm going to go down 1. So again, I could go up and to the left, but again, that's not going to take me to the graph. So I'm going to follow this change in y being negative and then change in the x being positive 1. So I'm going down 1 to the right, down 1 to the right, down 1 to the, did I change that? Was that supposed to be, did I write the problem wrong? Hold on a second, I made up the problem at the end. So that'd be 1, 2, dang it. All right, never mind. We're just going to change the problem here because I made this problem up on the fly. So that's going to be a 4. That looks good. Obviously, I want something that graphically is going to be easy to work with. So let's make that a 4. And I didn't verify these guys again, because if you don't give me a problem, I have to make it up on the fly. And I know a lot of you, I'm not sure, maybe don't understand, but like I'm not a textbook, so I don't have a lot of problems readily available to me to pick. So therefore, we have this point, down 1, that point, down 1, over 1. Okay, so you can see that the point where they actually intersect is going to be at 3, 1, where x equals 3 and y is equal to 1. And again, if we were to graph that, my graph is not stellar. So again, when I was looking at this, I just did some math in my head wrong. But you can see there is the solution, which is going to be 3, 1, x equals 3, y equals 1. Okay, number 6. So y equals e to the x plus 3. Find the inverse. So again, just remember the inverse, guys. We're basically looking into swapping the variables. X equals e to the y plus 3. And then solving for y. Well, we can't, when we're solving for an exponent or a variable in the exponent, we have to get that variable off the exponent. So in the common case with logarithms or with exponential functions, is to take the logarithm. So what I'm going to do is take the ln of x on both sides. The reason why I'm going to take ln is because I want to get rid of that e. So by using the rules of logarithms, ln of e y to the y plus 3 is just going to equal y plus 3. So again, that's one of the rules of logarithms that you can look at. And then again, we're just trying to solve for y. So we're going to subtract that. And then we will replace y with our inverse notation. I'm using a function. So we're going to say y inverse is equal to ln of x minus 3. I'll put that in parentheses just to make sure you understand that the negative 3 is there. And that's it. So basically swap the variables, solve for y. And again, one thing in logarithms that we cover a lot is, when you need to get that logarithm off the denominator, take the logarithm of both sides. Just make sure you choose the right logarithm for the base of the logarithm has to match the base of the exponent, which in this case we're doing e, so that's why I use the natural logarithm. All right, last question here, and then I'll get to some of you guys is it direct variation 2y equals 5x plus 1? And the quick answer is no. Y equals k to the x is our equation for direct variation. So when you look at a direct variation equation, we actually kind of did that. Like that is a graph, it's a line, and that's where a lot of people get confused. They think direct variation as linear, which it is, but the y-intercept is at 0. Like you just have a constant k and that's it. There is no intercept. So since this equation, no matter what you do to it, cannot be written in this format, it is not direct variation. No. And again, like you could solve for x, or solve for y. Y equals 5/2 x plus 1/2, like whatever. But again, it's not in the form y equals k to x. You cannot add or subtract to find that x and y intercept. So then the question also came into, okay, well, that's fairly basic. It has to be able to be written in this form for it to be represented as direct variation. Well, then, can you figure out some of these values? Well, again, so k is what we call our constant. So if y is 10 and k is 2, well, let's figure out and x is 2. Let's figure out what k is. So 5 equals k. So then it says find y when x is 12. Well, again, we now know what k is, which is 5 times 12. So 5 times 12 is 60. And there you go. So again, the really main thing with direct variation is knowing that constant y equals ktx. And I am done with all the problems. Oh man, this feels good now to kind of fresh up. I do apologize, guys. I'm not going to be able to do many problems, but I do want to definitely say hi to Eve, Easy Pie, Pori. Thank you for joining in. C-Valley, Easy Pie, I will eventually get to it. I'm not going to have time for the rest of this. Chat. Space Figgy, Duagain. Sorry, I'm just badgering your name really bad. I really do apologize. Good to see you, Tanner, Fancy Hippie. Thank you guys for joining in. Adeline, Molly, thank you so much, guys. I really do appreciate it. It looks like you guys have actually had some good conversations. So hopefully you guys are helping each other out. I mean, I always try to go back through the chat if I can, and if there's any other questions, but I really do appreciate any of you guys that are posting some questions, keeping that chat going. And then also for those of you that are helping each other out, because obviously that I'm just one person here. I cannot get to everybody's questions. And a lot of you guys have some great questions that you submit to me that I really like. I mean, obviously, to be honest with you, if I had the time, if I wasn't teaching a class tomorrow, I would just go live all the time and answer math questions. It'd be a pretty fun, interesting thing to kind of do. But unfortunately, I have to go back and teach tomorrow. So, Puta, thank you. Puts, not put. Thank you so much for the super chat. I really do appreciate it. Zarif, I'll give you a shout out. Hopefully I pronounce your name all right. Yes, Fancy Hippie. Brian, do you have any advice for future educators? Yeah, I got a lot of things I like to say about education. Nothing that's really kind of popping out of my head. I think just one of the things is, a lot of times, obviously with any job, you're always going to have ebbs and flows, with it. But I think one of the foundational pieces of advice that I've kind of always gone back is, always stay true to, why you wanted to become a teacher and why everything means to you, because there's so many things that happen within the educational world or at school with students, parents, administrators and stuff. But I think really just holding true and like why you want to be a teacher and the impact and stuff that you can have is one thing that can definitely keep you going. And that's, at least for me, that's really what's allowed me to keep going as far as, all the things that have kind of been thrown your way and, all the kind of craziness that goes on and the changes, really. I mean, crap. From where I was teaching, when I first started to where it is now, it's like completely different environment and situation. But I have a mission of why I wanted to become a teacher. And that's something that I still try to, hold true as far as every day when I'm in the classroom. Like, that's what motivates me as far as being a teacher. So I think just really kind of reminding yourself of that and really being the teacher that you want to become is some really powerful stuff. And obviously there's, people all over the world that need that from you, and they're not going to get it from somebody else. They need what your special gift that you can give them. So I really hope that if you decide to be a teacher, that's obviously that something you can, make an impact on a lot of other people. So I think it's great opportunity to be able to do. And it's one of those things that I'm very passionate about as far as, making sure that we are not having so many teachers leaving the profession or getting burnt out and stuff like that. So there is a lot more things I actually would love to talk about, but I'll just kind of leave it short and brief here for this at this moment. Molly, I see your question. That looks like a dangerous question. Transformations. Yeah. Unfortunately, I'm not going to be able to get to that as far as describe the transformations, sketch the transformations. It looks like based on your equation, you're going to have to do some maybe completing the square. I'm not really sure. I'm not really seeing as far as on that. So I do apologize. But if you want to send it to me for my next live stream, again, guys, I will be going live on this Wednesday. I will, in the community tab, I'm going to make a post right after I'm done with this live stream. So if you do have some questions, I do advise though, guys, if you have something you want to send me, like a picture, do that on Facebook, or if you have, something direct, but, if you can be a little bit specific, it's just kind of gets difficult sometimes to understand what you guys want me to actually teach. If you just kind of say direct variations, for example, but when you say, is this a direct variation? Yes or no? Or could you explain, when something is direct variation or not? Then I can kind of go off of that. Like, it's a little bit easier that way. So yeah, I really do appreciate you guys add in. I'm just not going to be able to get to any more questions, but I will be here on Wednesday, guys. And again, just feel free to join in on that community chat, and then we'll get some more of your questions answered then. And I'll maybe try to see if I can escape for a little bit longer and go from there. So otherwise, guys, you guys have a great night, and I will see you guys on Wednesday. Cheers.